Alrighty then. Hello. Today we're going to be building a pin 3 hot adapter cable, which is a pretty straightforward thing. So here we go. Alright. So I need one of these because I bought an old amplifier that was built in the late 90s. Well, that's when the manual's from. And because it's older, it doesn't have the modern pin 2 hot connection on its XLR connection. And I can go ahead and show you all that in this thing. So, in the manual, you can see that there's that for the inputs, they're marked as pin 3 hot. I mean, that's pretty difficult to see, in all honesty. But I couldn't find it on the spec sheet, so I had to find it on the back of the amplifier. And because it's on the back of the amplifier, I brought it home and discovered that I needed to do something about that. Now, in theory, pin 3 hot doesn't really matter, because all it should do is invert your signal. If you look at the way that you're supposed to wire an XLR cable these days, you'll see that the red cable, or the positive signal, is connected to pin 2, and the negative is connected to pin 3. Now, in theory, that shouldn't make a difference, right? I've actually mocked up this in Multisim, and I'll get rid of the grid because it's ugly. So, in the modern pin 2 hot sort of connection, you'll get the output stage outputting into pin 2, and with most, if it's depending on if it's unbalanced, the pin 3 will be to ground. If it's actually balanced, it'll have another inverting op amp on pin 3. But for our purposes, it can just be on pin 2, and that'll go into a differential input stage, which has the positive side of the differential input connected to pin 2. Now, in the olden days, that was not quite the case. You'd see that there's a pin 3. Instead, it would be pin 3, or it would be pin 2. Oops. Depending on what the manufacturer of your gear was. And this wasn't really standardized until the early 1990s, when AES put out a standard for interconnection, and everyone went to pin 2. So, in theory, this should make a difference because it's a differential input, and it'll just measure as inverted polarity rather than correct polarity. Dear Lord. I've been drinking, and I shouldn't be stuttering, but we're doing it anyway. So, in theory, that should work, but sometimes you'll have an unbalanced input. Now, I don't know how the input is managed on the oh Lord. Well, there will be some hopefully there will be no electrocution, but we'll see. So, oh, that's better. So, I don't know where I was. I lost my train of thought. Oh, yeah, so unbalanced input. So I don't actually know off the top of my head what the input stage of the amplifier, the Crest 4601 that I have is. It may be balanced, it may be unbalanced, and it may have a number of topologies. Now, if I were to just use a pin 2 hot connection and it was unbalanced, it probably wouldn't work because I would just end up with something like this, where the output stage of the previous, unit, depending on whether it's balanced or not, may or may not be connected to the input stage. And I don't want to deal with this. So because I don't want to deal with this, and I would like to have sound output, even though I could theoretically just put it into my, I could just plug an XLR output from any modern piece of equipment into it with no real worry. This may not be true for all equipment, and it would be nice to have a cable built for this purpose. So I'm going to build a cable that allows us to adapt and just swap pin 2 and pin 3. So that's what we're going to be doing today, or I'm going to be doing today. It's just me. There's no we. There's no we in I, and there's no I in we. So I've got all the essential supplies. I have a bunch of male XLR connectors. I have my female XLR connectors, and I've actually got a selection, but I'll probably just be using the standard Neutrik XX series one because it's really easy to use and doesn't require screws like these monoprice ones. I also have one that's from a Whirlwind cable, but I like the Whirlwind ones, and I want to keep these. So, and then I only have brand new ones. So, well, I guess you're right. Technically, there would be an I in we in that case. There'd be two I's. That would be, yeah, you're right. I'm sorry. I was just misspelling we. That was what was going on. So, I only have a brand new one, so I'll be using a brand new one today. I also, of course, have the cable to go between it. Whoops. Which is nice. And I just realized that I normally strip this using something else that I don't have at my desk right now, but that's okay. I, of course, have wire strippers for stripping cables because, you need that. And I think that's pretty much everything. Of course, I have a soldering iron. I don't have anything particularly fancy, but this will do. I'm just about to just turned it on, and it's set to about 500 degrees Fahrenheit. Now, I don't have a clamp or any sort of way of holding this stuff, so I will just be using gaff tape to help myself survive this trying time that we have together. So, while this heats up, I also have solder because you need solder. So, there you go. Over on my right, I actually have another thing which I haven't shown you all yet. I'm going to get really fancy probably, and I'm going to use heat shrink here on the connections I make just to make them nice. Or if they're really aggressive, then I probably won't use heat shrink. It depends. Somebody tried to make me use E-tape once to insulate my connections to XLRs, and I decided that was silly. So because this is going to be input on output, we're going to take I'm going to do the female end first. And the female end is going to be wired pin to hot, like you would expect. So you take the bushing off, the chuck, and then the connector out of the housing. Come on. Cool. So this is what I'll be working with. Pin 2 is marked, and it's going to be the one furthest away from me. So the furthest is going to be red, and the top one is going to be green? And this one's going to be black? I don't know. No, that one's going to be black, and then the top one will be green. Yes, the shield is probably going to be green. Or, in my case, it'll actually... the shield may have a drain. I haven't used this cable in a while, so I don't remember off the top of my head what exactly it is going to be. You can already see the cable wants to run away. Now, I'm not going to make a particularly long cable, probably just about 8 inches or so, to go ahead and have the gap. So I'm going to go ahead and cut it. And then the rest of my cable can go back into my electronics bin. Okay. Now, you'll have to excuse me. I screwed up and I forgot one tool that I use for stripping the insulation off my cable. So I'll be back in about 15 seconds. It's on my bed. You better be careful in there. Newton. Okay. That was strange. I found my cat in my speakers again, which is unfortunate because they're very expensive. All right, so this is what I use to strip my cable. I'd zoom in if I could, but I cannot. So I like to go ahead and take a razor, and I like to just roll it about 3/4 of an inch from the end of my XLR, my microphone cable, until I have a nice incision, and then I will run gently along as such, just enough to split the cable. You can see I do it along where you can't see, but I do it along the insulation. So you can see there's insulation there. I like to try and make sure I split along that. And then your cable just comes right off. Pretty easy, no real issue. Every now and then you'll lose some of the shielding on the outside of the cable, but that shouldn't be too big of a deal. Then then you go ahead and, well, see, I've split a bit too much of it. Well, no big deal. I'll go ahead and take the shield and unwrap it and twist it into my drain connector. Now, I have the option to, apparently this cable is red and blue, so relative to our wiring diagram from Rain, I'm going to go ahead and use the blue connector as the blue wire as my black wire. So that's what's going to be going on. I'm going to trim a little bit off the end of that because we won't ever be able to do anything with that at the end anyway. Cool. All right. Then there's the I don't remember what the name of this is. It's the bit that's the bit that gives it support or strength. There's an actual name for this bit of cardboard. I don't remember what it is off the top of my head though. And you know what? I've thought about it. I don't think I'm going to use heat shrink today. I'm just going to make it reasonable because there's no reason to use heat shrink on a cable like this. They're going to be so close together and there's not a lot of length to deal with, so it's going to be very difficult to fit the heat shrink over these little bits here and along this low length of cable. So no big deal. Now, I'm going to go ahead and do some prep work before I get started on the rest of this. Because when you don't have any soldering apparatus like a vise or a little holder, it becomes a big pain very quickly. Now I don't remember off the top of my head what to hold everything. So the better prepped you are, the better you're going to be. So I don't know what the gauge of this wire is. I'm going to take a stab in the dark and say it's probably 24 gauge stranded. Just a guess. We'll go from there. Now I'm going to strip off about a 3/8 of an inch. Oh, I just pulled that whole thing through the cable. That's not good. So we can push that back in. Well, that's going to be an issue. I just pulled that whole pair through. That's scary. Oh well, we'll make do. We'll just strip some more off. Hold a little bit tighter on the cable this time. And then we'll match on the other side. These cutters have been through a lot, I think, because they don't really want to cut. I say as if they aren't mine and I shouldn't know what they've been through, but you do a lot of different projects and you don't always know everything you've done with your tools throughout the years. So yeah, 24. 22 was not tight enough to get the insulation off, so there you go. All right, so now we've got the pair completely free, and I'm going to go ahead and tin these ahead of time so that when we go to put them on our connector, they already have solder and it flows nicely. So I'm going to go ahead and clean off my tip. I always leave solder on it when it's not in use. Now, I suggest using flux, but I don't have access to flux today, so I'm just going to use the rosin core of my solder as my flux. Go ahead and tin my tip a little bit, wash it off some, go ahead and wipe it again, and then we'll go ahead and tin it again. Okay. Now, I'm going to go ahead and arrange these how I would like them later, because I'm going to work probably on this left-hand side here. Yep, okay, and they're going to be arranged so that they line up nicely when they go into their final destination there. So I'm going to go ahead and take some gaff tape and tape my cable down so it doesn't rotate, and it will be easy to use. It will probably rotate a bit, but this is just enough that it won't go a bit too crazy. All right, I'm going to go ahead and tin the copper braid. Well, it's actually not a braid, it's a spiral first. This is really small stuff. I wish I had a closer camera, but this is the only way that I have. I haven't been able to come up with a better setup yet, so here we are. Now, hypothetically, this will just flow onto the... There you go. Once you heat it up enough, it'll just kind of flow onto the braid and onto the copper, and you won't have to force it too much. So that's always what the goal is for me. Whoopsie daisies. And these are such thin conductors that you really don't need much heat at all to get them to flow. Yeah. The amount of solder I had on my tip was already too much. So then I'm going to do the same process for the cups. Go ahead and heat them up a bit and tin them. They really don't take too much. They are designed for this. Go ahead and fill them with some solder. Not too much, just enough that they're wet all the way down the length. Again, you can't really see, but adding just enough so that it flows. All right, now I'm going to double check and make sure that I have this order done correctly. I do not have the order correct. So pin 1 is actually at the top of this connector. Pin 3 is in the middle, and pin 2, our hot pin, as you'll remember from my original spiel, is at the bottom. All right. Now, typically, the one that's the most difficult when you have the cable twisted weirdly like this is the middle one. So I'm going to go ahead and do that one first. Go ahead and touch both. Again, I don't have any tools to make this easy, so I'm going to have to touch both the wire and the cup at the same time, and then kind of just gently encourage it to go into the solder cup. Just gently. There you go. And once it's in there, add a little bit more solder, not too much. Yep, there it goes. And hold it as still as you can while it cools. That should be just enough to get it to hold. Yeah, it's not my best work, but you all can't see because it's too small on the screen. Ha 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 ha. Now, the hardest one is probably this one, because you can't really... I actually remember now, it's been a while. You can't hold the copper because there's no insulation, and it heats up really quickly, so this is actually the one you want to do first. But, it's been a while since I've worked on these, so cut me some slack. All right, clean a tip, make sure it's tinned before we go in. You always want to have a wet tip because that's what allows heat to flow. Go ahead and heat up the solder on the wire. See if I can't get it into the cup at the same time. Add some solder to the cup and the wire. Let it run away for a minute because you're bad at what you do, like me. Heat it up again. Force it in there with some finesse, using the tape to prevent it moving too much. Immediately tin your tip after cleaning it so it doesn't oxidize. Also, never apply flux directly to your tip. Just a pro tip about cleaning your tip. It's a bad idea. Generally not recommended by any of the manufacturers I've seen. All right, now there's actually a little of solder at the tip of that one, which I don't really like, so I'm going to use the soldering iron to kind of absorb and pick up some of the solder. There we go. And now the last one to get all the way to pin 2 in, and this will be our hot again. So we're almost in the cup, and now I can just add some solder. All right, now I want to mention, I would like to say, for anyone watching who does this professionally, this is clearly not excellent soldering work, and I am sorry on behalf of myself and anyone else who solders this way. But I don't have access to really great tools right now, and pretty much everything is going to pass signal just fine, and thanks to the miracle of the no-trick chuck and bushing, we're going to be just fine. All right. Now, go ahead and take the tape off. It's still a little warm, but it should be just fine. We want to make sure, typically you want to make sure that you've put all this on the connector, the cable, before you put the connector on. But since this is the first one I'm doing, I don't actually have to worry about not being able to slide things on at the end. But in most cases, you'll have to worry about that. So watch out for that before you have yourself. Now you'll see, I'm going to double check real quick that I've got all the pins correctly in. 1 is shield, that's correct. 3 is neutral, negative, and then 2 is positive, red. Okay, good. Red will be our positive, blue will be our neutral or negative, and then our shield will be, as said before, it will be our shield. Okay. Cool. So that's how the bushing just goes on. It fits in these little slots on the side of the connector very nicely. And then you go ahead and you take your bushing, you slide it on. I like to do this before I put the other bit on just because it's a little bit of a pain. You should see that the hole is originally smaller than the cable, but as you push through, I suggest not stripping this end of the cable before you put these on. And you push it through, and it ends up stretching just enough, which is very nice. So, okay. And then finally you take the housing, put it over the connector, and go ahead and push this together. Now there's a screw on the end of the bushing, and on the inside, there's threads on the inside of the housing. You just go ahead and screw this on. Some people like to just do it finger tight. Hi, Jamie. Good to see you. I like to get it fairly tight so that it's watertight and it's not going to come undone. And also because why would they allow you to tighten the connector if you weren't supposed to do it? So now we've got 1/2 the connector built nicely and easily. Now you'll notice when I was working with the cable, I don't have an OnlyFans yet, but when I make one, I will make sure to let you know immediately, Jamie. You'll be the first one I call. Again, I'm going to use the razor to take the outer jacketing off. The important thing here is that you don't really want much pressure. If you use too much pressure, you'll end up going through the cable. Now, I've actually done a really bad job this time, but sometimes you can. Yeah, I haven't actually gone through. I didn't use enough pressure, so I guess ignore what I just said. I don't know what I'm talking about. You got to use a whole bunch of pressure, or at least you got to pass a couple times, and then it should kind of just pop right off the cable. If you get excited, you can go and slice down the side. I think my issue is I just haven't cut through. Yeah, there it is. Okay, and then it should just slide right off. All right, cool. This goes in the trash. All right. Again, we're going to go ahead and unravel the shield and twist it together to make a drain wire for us to solder to. We're going to leave the cardboard support in the middle. We're going to go ahead and snip that off in a second with the scissors. I wish I could zoom in on this, but I cannot. You'll see where how we pulled the cables through last time, the wires through last time. They're shorter than the drain, so we'll just snip the drain a little bit shorter and the blue a little bit shorter, and they'll all be even. It'll be a little short for the connector, but it should be okay. Go ahead and snip all this cardboard support. I've got to figure out what the name of that is. I used to know, but I don't remember anymore. That's it for our box cutter or razor. That can be put away. Hello, Kittine. My cat's watching me from the floor next to me. He's very sweet. All right. So, we need to make sure to strip this before I forget. Again, this is probably 24 gauge. That's what I found worked best. but I don't know. I'd have to look it up for this. This is actually I stole this from a microphone cable that broke. It was a live wire cable, and the connectors were really crappy Chinese Neutrik knockoffs, and they just did not last. And so I didn't have any spare connectors, so I just removed the connectors and kept the cable, and I've used it ever since. All right. And now you'll notice I'm twisting these cables after I strip them. That's just so that they don't fray as much when you're using them. You don't want to go too crazy on them because then they'll start fraying anyway, just from how much you're twisting them around each other. Again, I'm going to go ahead and tin them. I'm actually going to tape it this direction. Oh, this is a great learning moment. I've made a terrible mistake. I forgot to put my bushing on. And I'm glad I did that and saw that now. The problem with forgetting to put your bushing on is that now you have to stick these tiny fragile things through this little hole. But that's okay. This is not the first time, and because they're all slightly different, they should be pretty easy to get in a line like this and just kind of finesse right through without too much issue. And you can always retwist your wires afterwards. I keep calling the wires cables. I'm sorry. All right. Now, because this is our output side, we're going to be wanting to mount to pin. We're going to do pin 3 hot. I'm amazed you didn't say anything. Actually, I'm not amazed you didn't say anything. I would have expected nothing less from you all. It would have provided excellent content, but I know better than to do that, or at least enough that I can catch myself while I'm doing the thing. I assure you it will happen at some point. All right, again, we're going to tin our wires ahead of time. Oh, I actually said I was going to cut them to size. I'm going to do that with the drain wire because it is the one that makes sense to do that with, but the other ones I would like the extra length. So I'm not going to remove anything from them. And these I need to sharpen these. I don't know how you sharpen wire strippers, but those cutters in the middle did not last. Or maybe I just need to get separate wire cutters. That could be a thing I do once I have money again. Once any of us have money again. That's topical now, but it's gonna be so off topic come like a month from now. All right, again, I'm gonna tin them for real this time. I swear, I promise, I'm actually tinning them this time. I'm not just pretending to for clickbait reasons. What I do need to get for sure. Oh my god. Well, sometimes this just gets really fiddly. I actually do need to get one of the like fume things, the filters that whisk away all the fumes from this, so that I'm not slowly killing myself with the fumes. Now this wire here got beat up really bad. What are you all on? My cats are going crazy. Maybe it's the solder smell. Maybe they're very confused about this. You don't want to touch this. You don't want to touch that. That's very hot. Oh my god. I'm hearing like bottles and bags bouncing around my apartment. That's questionable. Now, you may be wondering, do I care about this table? And the answer is no. I've been soldering on this table for about 4 years now. It is beyond destroyed, and it turns out the solder just scrapes off, so no big deal. Oh, jeez. Another thing that'd be nice for this is a solder pot. A solder pot allows you to tin your wires like this really easily. Just heat it right to the correct temperature. Put your cables right in it. No big deal. All right, now I'm going to do something a little bit crazy this time around. I know better than to try and hold this connector here. So I am actually going to tape my connector down just lightly like this, knowing full well that this is a bad idea. As you may know, as you heat up the tape in gaff tape, it melts and then it starts eventually drying out. So I really have a time limit here in my solder cups. So they're not too hot, but they are still hot enough so that the solder flows. Okay, so there we go. So let's make sure these are, I've got the labels right. Okay, so this is going to be our output, and this is going to be pin 3 hot. Now, pin 3 is our bottom pin. Pin 3 is our top pin. Pin 1 is the one that's the furthest on the top screen, on the top of your screen, and closest to me. And then this pin here on this side is pin 2. So pin 2 is going to be blue this time. And then pin 3 is going to be red pin 3, the top one is going to be pin 3 hot, so it's going to be red. All right, now to facilitate that, we're going to arrange our cable ahead of time so that that'll work. I've got my bushing on. I double checked to make sure that wasn't a thing. And I'm going to start with the non-insulated ground wire first because it's the one that makes the most sense. I'm actually going to go ahead and clean this up a little bit now that I have some solder on it. Cool. All right, so go ahead, tin my tip a little bit, get some flux on there just to help clean it because it looks to be some buildup. Go ahead and just wipe it. Now, it's fair to say that using a sponge causes thermal shock to the tip. And in all honesty, I would like to not have to use a sponge. But unfortunately, using those like brass things just don't work. The brass like meshes that you can use just do not work well. So in contrast to the last time where I was moving I'm really blocking your view of this, so maybe I can do it like this. In contrast to last time where I was moving the connector, I am this time moving the cable and the wire to the connector because I can't hold the connector because those pins all get very hot and there's no other way to hold it than to use the pins. So, also that's very warm. All right, pin 3 is now going to be our next target. Actually, better yet, we'll do the blue. We'll do pin 2, which is our blue, which in this case is our negative, or our cold, as some people will call it. All right, I'm going to start by, this is a really difficult thing to finagle right now because of how much this does not really want to stay taped down, but we're going to make it happen. I am in command. So I'm going to bend my wire. I don't know if you can see that, but I'm going to bend my wire ahead of time so that I can heat the solder cup and then rotate this into the connector so that I do not have to deal with it too crazily. If this doesn't work, I will have to break out the tweezers, which I'm not necessarily opposed to, but as you will understand, is kind of a pain, and I don't want to have to do. So, make sure it's bent correctly, or at least enough. Clean my tip, tin my tip to make sure that heat can flow. Go ahead and heat up that solder cup. And then I'm going to rotate my cable, my wire. See if I can't get the wire into there. Yeah, this is just going to be a complete mess if I do it like this. I'm going to have to use tweezers if I can't fiddle with this. I could just shorten the wire and that would work nicely. It would be nice if I had viewers to ask questions about things like, what soldering iron do you recommend for a beginner? And then I'd go, I don't know. I'm a beginner and I use this one, but you can't buy this one because this one is no longer in stock, which is why when I went to try and buy, a close friend of mine one, a couple months back, I discovered that I had no idea what to purchase her. So I am still looking for the correct one at a reasonable price so that I can purchase one. I can provide the joy of soldering to my community and friends. All right, I managed to get that in there. I'm going to double check that's numbered correctly, because I cannot tell you the number of times I have failed to successfully get things in the right place. Okay, pin this here is the last one is this red wire. This one is very close to the correct spot already. I'm going to put this down so I don't burn my keyboard by accident. Okay. I have to get a new piece of gaff tape. Yeah. That one is all used up. It's too hot. It's heated up too aggressively. All right. Now, go ahead. Whoop, forgot to tin my tip. And that's why heat wasn't flowing. I might have an oxide layer on it. You never want to be fighting the oxide layer. Always wipe it off. See if you can wipe it off. And if you have some rosin core flux, see if you can use that to get started. Because the flux in the rosin core will do a really great job just kind of gently removing the stuff from the tip. And the solder gives it the impurities plenty of places to go. And it prevents the overall amalgamation, I guess, the amalgam. I don't remember the exact science. It prevents the flux from immediately boiling off and leaving residue. So, pretty solid strategy, if I do say so. All right, this one's going to be pretty lame. I'm just going to kind of shove this one in here because it's just not working very. This is I should apply a little more solder so that the heat can flow. All right, I'm just going to kind of see if I can't fudge this in here with my great fudging skills, but I don't expect much. Yep. All right. Well, there's a connection made, and I don't really expect a lot more than that. Cool. That should be it for our soldering iron. I'm going to go ahead and turn that off and put that over to the side. Make sure it's out of the way. And then go ahead and remove all this tape because it is now used and will never stick to anything again. And you'll see our cable is bent, but that's no big deal because you can see already. Oh boy, there's actually some buildup from the gaff tape I need to now scrape off. Another great use for the razor blade is scraping off gaff tape residue when you don't have a vise, and so you use gaff tape instead. It just comes right off. In fact, if you're really aggressive, you can even get the coating, the zinc coating. Not the coating. It's not zinc coating. I'm sorry. Whatever it is. Whatever they use on the surface. I don't know if it's actually a coating or whatever. But there you go. Already nice and cleaned off. There you go. And now it'll work just fine. If that doesn't work, you can always use isopropyl alcohol. It will work just fine. Make sure to be using 90% or higher, and you'll have no issues. You can buy isopropyl alcohol in bulk without too much issue. So we can just straighten this out, twist it up, twist it a bit, and then we're good to go. So there you go. Now we do the same process as we did before. You have your housing, bushing, connector, and your chuck. Go ahead. Actually, this may be the bushing and this may be the chuck. I'm pretty sure this is the bushing and this is the chuck. If somebody wants to look it up before I do, I would be most appreciative. I always have the opening in the chuck facing upward towards the top of the connector as such. So if the top of the connector is here, the part of this that splits open at the top is facing upward. With that, I don't know if that's how it's supposed to go. That's just how it comes in the package. So I like to do it that way. It seems like it's symmetrical and it can go either way. Once that's nice and tight, I like to hold it there, hold it there, make sure it doesn't go crazy. Then you want to bring your bushing up, put your connector in. There's only one way that this connector goes, and that's because there's a little pin that orients the connector. A little slot. You can see it in the connector right there. That orients the connector, and so the XLR has to be correctly oriented. And you can see there are 2 alignment slots in the connector right about there. There you go. And there's the second one. So those match up with these 2 little notches in the connector right here. And so you just line it up and go. Also, the note trick is on the top, so if you know, you can just line that up real quick. Go ahead and slide that in. Once it's in all the way, you can tell because the black is flush with the little ring. Just go ahead and push the bushing in until it attaches to the screw bit with the housing screw, and then screw it on. And there you go. Now I've got a little connector. It can't connect to itself because I made it too short, but that'd have been a really cool way to go. All right, so I'm pretty sure we're done with the solder, so I'm gonna go ahead and put that back where it should be. And I'm gonna put the soldering, the stripper to my left, but we're not quite done. It's always important to test your cables before you put them out in the field. And so I'm gonna grab my trusty multimeter and see if I can't make sure that all this stuff is set up correctly. So I'm gonna go ahead and do ohm resistance. I'm going to do 200 ohms because we'll be able to read the exact resistance. And if it's anything more than maybe an ohmish, maybe half an ohm, we should have issues. Now, the first thing we should always check is we should always check pin 1. Pin 1 is what you should always check first because pin 1 is your shield. And that's usually easy to get right, especially in an adapter. That's always a good reference to make sure that everything is working. Now, if I bring this over here, you can see it's 1 right now because it's overloaded. But as soon as I touch it, you'll see there's a very, very small resistance. If I can hold it for more than a second at a time. Point is, I'm being a little bit of I'm having a bit of a shaky hands moment, but point is, it's good. Now we know that on our connector here, we want pin 2 to be hot. So here we're doing pin 2 hot, but over here we know that pin 3, the middle pin, is our hot pin. Still got some crud on it. Removing that tape residue. Okay, so now go ahead and touch that. Make sure that's connected up. All right, good. We see a very small resistance between pin 2 on our input and pin 3 on our output. That means we wired it up correctly, and that's working. Finally, we want to check our cold. So you go ahead and stick that in pin 3 over here. You'll see me holding it like this. I'm using my index finger and my thumb and my pinky to apply pressure to make sure that the probe is touching the contacts on the inside of the XLR. It's a really good trick. And you can use those last 2 fingers to hold the other connector like this so you have good access. So let's check pin 2. I'm going to make sure I know which one's which. I don't do this all the time, so if you'll have to forgive me. Okay, pin 2. Okay, so now we can touch pin 2. And we should see that should have a very small resistance, which it does. Excellent. So we know our adapter cable works correctly. Or at least that it should pass signal. It's wired correctly. Now, I don't actually have any test equipment. If I had test equipment, I would go ahead and plug this in and make sure that it actually passed signal the right way. But I don't have any of that equipment hooked up, and I wouldn't be able to speak into my microphone if I did. So there you have it. I've gone ahead and made an adapter cable that goes from this new standard with pin 2 hot on the XLR to this old pin 3 hot standard. I've made sure that everything is soldered nicely. I made sure to tin everything before I connected it up, and it worked a lot. It was I showed you that nice trick with the gaff tape because otherwise, how the heck are you gonna prevent it from moving? You just need 3 hands otherwise. If you don't have a vise, it's on my list of things to get, but normally I have access to more tools than I do right now. So you can use that trick whenever you want. And we've made sure to test it after we were done so that we are confident that it should work going into the field. That's about it for me today. If you have any questions, you can leave it in the comments. You can also send me a message, and I'll try and read everything. So thanks for joining me, and hope to share some more interesting stuff besides just an adapter cable in the future. Maybe some nice, easy board repair I still have this direct box to fix. It actually works now. At one point it didn't work, but I've messed up and I've broken one of the switches that I need to replace. It was broken before, and I ordered a replacement one. I ordered a pair of replacements, and then in replacing both of them, I screwed up one of the replacements. So and the only way to get them off is to physically destroy them. They just have too many solder points to get off at the same time. So yeah, it's unfortunate, but I still need to go ahead and open this up, and it would be good to take a look at the inside of a DI box, even a very cheap one like this. So I don't know. Send me requests. Let me know what you'd like to see. I'll probably do some amplifier repair at some point. I have a whole adventure to take you all on with me because I need to repair an amplifier that I don't know how is broken. So until next time, have a good evening.